All right, so we are recording. We're a little bit into the lesson. So to recap for those who are following along after the fact, we are covering 6.2, an open and shut case. It's page 25 in the packet, page 27 in the workbook. Malia has already answered the first question, which locker numbers does a third student touch? We landed on 3, 6, 9, 12, 15, 18. We talked about how each of these numbers here is a multiple of 3. Okay, so now we're in the second problem. Which locker numbers does a fifth student touch? Camila, do you have an answer for that one?
5.
Okay, so starts at 5.
10.
Yeah, so we jump to 10, all right.
15.
15.
And 20.
And 20, very good. And I'll ask you the same question as I asked Malia, Camila. These numbers here, 5, 10, 15, 20, are these factors or multiples of 5?
Multiples?
These are multiples of 5. Very good. Because remember, when we skip count by a number, those numbers we land on are multiples of that original number, the starting number. Right? We can multiply 5 times some number and get 10. Sometimes some number to get 15. 5 times some number gives us 20. Right? When we skip count by those numbers and land on it, those are multiples of the original number. Very good, Camila and Malia. Problem number 3. How many students touch locker 17? Explain or show how you know. I see Malia's hand. I want to get somebody else involved too. I see Camila's hand. I want to get somebody else involved too. I'll come back to you girls for a later question. Elizabeth, how many students touch locker 17?
2.
Yeah, how do you know that? What did we do in our diagram to show? How did we show that, Elizabeth? Elizabeth, are you there? How did we show that only 2 students touched the 17th locker? What did we do in our diagram? You kind of cut out. Can you try that again? Camila, do you want to help Elizabeth? I saw your hand raised.
So 2 students touched it since we kept track of which ones touched it.
Okay, how do we keep track of it in this diagram?
Skip count?
Yeah, we skip count it, and then what do we put on our paper? What are these up here?
Dots?
Yeah, we put dots for every single student that touched a locker, right? So you can keep track of what lockers were touched and how many times. Okay. For problem number 4, which lockers are only touched by 2 students? Explain or show how you know. So which lockers, I'll zoom in nice and close. Which lockers were touched by only 2 students? What do you see?
17.
Okay, yeah, there's 17. That's touched by 2.
7.
7.
2,
2,
3,
okay,
19, 5, 11, 13,
yeah, very good. So it looks like there are 3, 6, 8 numbers of lockers that were only touched twice. So I'm going to write those numbers down right here. So which lockers were only touched by 2 students? We had 2, 3, 5, 7, 11, 13, 17, 19. Okay, and we can explain or show how we know, but we already kind of discussed that in the previous problem, where we said we looked for the number of dots on each of those lockers, because that's how we kept track of how many times that locker was touched. So 2, 3, 5, 7, 11, 13, 17, 19. Okay, let's go back up. Actually, go back down. Problem number, is that 5? Which lockers are touched by only 3 students? Explain or show how you know. So let's scroll back up. Which lockers are touched by 3 students? Elizabeth, what do you think? What lockers are touched by 3 students?
4, 9,
Yep, 4 and 9. Any other ones?
no.
No, no other ones? Yeah, I agree. 4 and 9 are the only ones that were touched 3 times by students. Okay, so we can write 4 and 9 down for problem number 5. Which lockers are touched by only 3 students? Locker 4 and 9. Okay.
Yeah.
Now, the reason why it's asking us these questions, because we need to be able to make diagrams that are easily readable. Right? We had a very, how do I want to describe it? Very complex, complicated game or problem that these kids were playing, right? Each kid touched a locker at different rates for different amounts and different lockers. So there's a lot going on here that we need to keep track of, right? So we need to be able to create a diagram that is easily readable, that we can come back to and get information from, so that if someone asked us, all right, which lockers are touched by only 3 students? We were able to do that because we made a nice, clean, clear diagram for us to use. All right, so that's why it's asking us these questions. Which lockers will be touched the most? Explain or show how you know. So which lockers were touched the most? Camila?
20,
Okay, 20.
18,
Nice. 20, 18.
16,
Yeah, 16. Has 1 less, but it's still touched quite a bit.
12,
Yeah. Yeah, very good. I'd say those are definitely the ones that are were touched the most by the students. In fact, 12, 18, and 20 were touched 6 times each. What do you notice about those 4 numbers, 12, 16, 18, 20? Is there anything in common between them? Anything that stands out? Camila, go ahead. You can keep going.
The numbers remind me of skip counting almost.
Okay, they remind you of skip counting. It doesn't look like there's, I do agree. It doesn't look like 12 and 16 has the same jump as 16 to 18 to 20.
Yeah.
But it does look like they are skip counting, right? There's a gap between those numbers. All right, thank you, Camila. What's something else that you girls notice about 12, 16, 18, 20? Maybe about how big they are, even, odd. What are you thinking? Is there anything that stands out? Camila, you have another idea?
They all have ones in front, except for 20.
Except for 20. So they're all maybe bigger than 10.
Yeah.
One.
All right, so they're all bigger than 10. They're all bigger numbers. Okay, Camila, are they even or odd?
The first number, the one.
So 12, 16, 18, 20. Are those even or odd numbers?
12 is even.
Okay.
16 is also even. Yeah, they're even.
They're all even?
Yeah.
Yeah, very good. So they're all bigger numbers. They're all even. Now, do you think that that gives it a reason, or gives us a reason as to why those numbers are landed on or touched more than other numbers? What do you think? Think about factor pairs. Think about our factors that we've been talking about and how we made our factor rainbows, and some had more bands on the rainbow than others. Some could make more rectangles than others. What are you thinking?
Open. Oh. Open. Open.
Let's think about the factor pairs for these numbers. Remember when we make a factor rainbow, let's say we're going to do it for 12. When we make a factor rainbow, we start with 1 and the number, always, right? We said that that's always a possibility for a rectangle or for a factor pair with a rectangle with those side lengths. 1 and the number we're looking for, so 1 and 12. We then go on to 2 and try 2 and see if that works. Well, since 12 is an even number, and if we skip count by 2, it's always even, we know that 2 can go into 12. Right? In this case, it actually goes in 6 times. Okay, so we have 2 and we have 6. We then go on to 3. Well, if we skip count by 3, 3, 6, 9, 12, we land on 12. So we know that 3 is a factor of 12 because we can skip count by 3 and land on 12. And so 3 times 4 gives us that answer. What do you notice about the amount of times that locker 12 was touched and the amount of factors that it has? What do you notice about the number of times that the locker was touched, the number of dots, and how many factors it has? What do you think? Are you understanding my question? Camila's giving me sideways thumbs. Okay. Thank you, Sarah, too. So it sounds like I need to restate my question. So when we're looking at 12, we're looking at locker 12 and we see how many times there are dots, how many times the locker was touched. Okay, I see 6 dots, don't you? See 6 dots above 12, meaning that 6 students touched locker 12. But when I make my factor rainbow, I have 1 and 12 matched up. I have 2 and 6 matched up. I have 3 and 4 matched up. I'll even write these out as multiplication problems so we can see them. You see how there are 6 numbers here, 3 factor pairs, and since they're in pairs, there are 6 total numbers here.
Yes.
Yeah. So each of these factor pairs here, well, I guess I should say each individual factor, 1, 2, 3, 4, 6, and 12, for the factors of 12. These are the students that started out at these lockers and skip counted by that value. So the first student who started at 1 and skip counted by 1 and touched every single locker touched 12. The second student that skip counted by 2, so 2, 4, 6, 8, 10, 12, landed on 12. The third student started at 3, skip counted by 3s and went 3, 6, 9, 12, and landed on 12. Fourth student, 4, 8, 12. Sixth student, 6, 12. And the 12th student, of course, started on 12, so they touched it then. Okay, so each of these dots actually represents a factor of that number that the locker is. So there are 6 factors of 12, and we have them listed here. 1, 2, 3, 4, 6, and 12. Does that make sense?
Yes.
That each of these dots, it does make sense. Each of these dots represents a factor of that value.
For me,
So
it
what do
makes
you
sense.
notice? I'm gonna highlight this again. So let me erase all of these. Okay. Let's look at those numbers that had 2 dots. What can you tell me? Let's see, how do I want to ask this? What are the factors of those lockers that I highlighted there? 2, 3, 5, 7, 11, 13, 17, 19. What's the factors of, let's start with 2. What are these 2 dots? Which 2 students touched the second locker? Camila?
Blue and green.
So blue and green. Which one was the blue student? Which number?
2.
So green was 2, and I know I ran out of colors, so they don't really line up. Like there's multiple reds, multiple blues, things like that. But remember how we said that for factor pairs of a number, we always have 1 and the number, right?
Mm-hmm.
We always have 1 and the number. So using that reasoning, we know that 1, so the first student, touched that locker. And then we have the second student touch that locker too, because that's where they started. So we have the first student and the second student touching that locker. Do you see that? Does that make sense?
Mm-hmm.
Okay, and that's why we have the 2 dots, because we have the first student touching, we have the second student touching. Now what about the third locker? What students touched the third locker?
Blue and purple.
Blue and purple. And what number students are those?
2.
So
Oh.
did the first student touch the locker?
Yes.
So here, let's backtrack a little bit. So remember, the first student touched every single locker because they started at 1 and skip counted by 1. So they started at 1, they skip count by 1 and touched the second locker, touched the third locker, touched the fourth and the fifth, the sixth, the seventh, the eighth, all the way on up. Second student started at the second locker and skip counted by 2s, so 2 to 4, 4 to 6, 6 to 8, and only touched those lockers. And every time they touched a locker, we put a dot. The third student started at the third locker. We put a dot on the third locker. He skipped counted by 3, put a dot on the 6th locker, skip count by 3, dot on the 9th, dot on the 12th, dot on the 15th, and so on. We did that for each of these lockers, each of these students. So if we're looking at the third locker, the first student touched it because they touched every single locker. So I can put a 1 there for the first student. And then the third student touched it as well because they started on the third locker, put a dot on it, and skip counted the rest of the way. So the first and the third student touched the third locker.
Oh.
Does that make sense, Camila?
Yeah.
Okay. What about for the 5th locker? Because there's only 2 dots on the 5th locker too. What 2 students touched the 5th locker?
1 and 5.
Yeah, 1 and 5. Great. The first student, because they touch every locker, and the 5th student, because that's where we started. Okay, let's keep going. What about the 7th locker?
1 and 7.
Yeah, 1 and 7. All right. Do you see a pattern here?
Yeah.
You should start to pick up on the pattern. The first pattern or the first number is 1 and the second number is the locker that we're working with because that's the student that started with the 11th locker only touched the 11th locker. All right, so we have the first and the 11th. And then for 13th, we have the first student touching it and the 13th student touching it. For the 17th locker, we have the first student touching it and the 17th student. And for 19th, we have the first student touching it and the 19th student touching it, right? Those are for the numbers that, or the lockers that only had 2 dots, only 2 touches. It was the first student and the number themselves. Okay. Now we had a vocab word that described these numbers. So we said that each of these dot represents a factor, right? And if we have 2 dots, that means we have 1 factor pair, right? Because a pair is 2. So if we only have 2 dots, meaning 1 factor pair, what are these numbers that we just listed?
Multiple?
Okay. Yeah, they are a multiple of those 2 factors. But is it prime or composite?
Oh. Composite?
So if we only have 1 factor pair?
Prime?
Yeah, so they are prime numbers. And the reason why they're prime is because they only have 1 factor pair. And that is 1 and the number. You see how these factor pairs here, 1 and 2, give us 2. 1 and 3 give us 3. 1 and 5 give us 5. So the only factor pair that they have are 1 and that number. Does that make sense?
Yes.
Yes, you can ask questions if you don't understand. And that goes for Camila or anybody. Okay. So if those numbers are prime numbers, what are the names of the other numbers? Like 4 and 6 and 8 and 9 and 10. You said prime for
Composite.
these and composite for the others. And the reason why it's composite is because there are many different factors. Multiple ways of getting those answers. Okay, can I see some cameras and give me a thumbs up, sideways down? Show me I'm getting this. I know what prime numbers are. I know why these listed numbers are prime. Sideways is I'm kind of getting there, but not quite yet. And thumbs down is I'm not sure. I need some more help. Okay. So I see sideways and up. Okay. Okay. We will review this page tomorrow at the very start of class, review what prime and composite numbers are with a little entry task. I'll even write it down so I don't forget. All right, so an entry task with prime and composite so we can review some more examples of each. And then we'll get into our lesson tomorrow on factors and multiples and get a lot of practice with factors and multiples, because I know it was either yesterday or the day before. Can't remember if it was your class or not, but you just said you needed more practice with factors and multiples. So we're going to do a worksheet together, have some independent work time as well, so that you can get a lot of practice in prime and composite numbers as well as factors and multiples. Okay, because we spend a lot of time with just me talking and instructing instead of giving you some really good extensive practice like you would in a normal classroom, right? You do a lot of worksheets and practice and all different kinds of problems. We haven't had a great chance to do that. So we'll do that tomorrow, give you a chance to work on some things, wrap up this unit. We're just finishing up this unit. So I want to make sure that we're all in a good spot for the quizzes and tests and things that we have next week to make sure that we're all learning what we need to learn. Okay, so I'm going to stop recording.